The same strict and slack inequalities can also be with the two variables. See here we have ax plus by. Here the value of a and b cannot be equal to 0 because the degree of x and y should be equal to 1. 180 less than 200, it's a true statement. So that means the solution set should make the given inequation as a true statement. I'll divide by -5 on both sides, then I'll get x greater than or equal to. So since we are dividing by -5, it is 8. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. In this session, we are going to discuss about the linear inequalities. So let us see, what do you mean by linear inequalities? We know the equality of two algebraic equation. When that equation is replaced by the symbol greater than, less than, greater than or equal to, or less than or equal to, we call them as linear inequalities. We know linear is nothing but degree 1 in any algebraic equation. For example, 5x minus 3 is equal to 0 is an equation with power of x as 1. So we call it as a linear equation. If suppose the same equation is replaced with less than 0 or greater than 0, we call them as inequalities. So two real numbers or two algebraic expressions related by the symbol less than, greater than, less than or equal to, or greater than or equal to forms an inequality. So now inequalities may be of the any form. When the inequality is with less than or greater than, we call it as a strict inequalities, and when it is with the equality, we call it as slack inequalities. The following are the examples or the general type of examples for linear inequalities. Now here we came across an equation ax plus b less than 0. We should know that a cannot be equal to 0. If a becomes 0, then we can't say it as a linear equation. So therefore, considering a not equal to 0, ax plus b less than 0, ax plus b greater than 0 are called strict inequalities in one variable because we have only one variable. Similarly, if the same equation is replaced by less than or equal to or greater than or equal to, we call it as slack inequalities in one variable. The same strict and slack inequalities can also be with the two variables. See here we have ax plus by. Here the value of a and b cannot be equal to 0 because the degree of x and y should be equal to 1. And c, similarly ax plus by greater than or equal to are called as strict and slack inequalities if they have the same type of equation. We can also have a quadratic equation here, ax square plus bx plus c less than or equal to 0, ax square plus bx plus c greater than 0, or quadratic inequalities. So these are the general examples of an inequalities. Now rules for solving inequalities. So we have learned the LHS and RHS method shifting process while solving the equations, but here when you're solving inequalities, we have certain rules to follow. How to solve those inequalities now? Rule number 1 says, adding the same number or expression to each side of an inequation doesn't change the inequality. Suppose we have x minus 3 is less than 0. I need the solution for x. So what I'm supposed to do? I'll add a 3 on both sides. So when I add it, minus 3 and plus 3 get cancels. 0 plus 3 is 3. So the solution is x less than 3. We can't shift the values to the right hand side as well as left hand side. The process is we need to add the same thing on both sides to remove some quantity. Similarly, when you are subtracting any number or expression from the left hand side as well as right hand side, you should add and subtract the same number or expression to each side of an inequality so that it doesn't alter any changes in the inequalities. That is rule number 2. And rule number 3 says multiplying or dividing each side of an inequation by the same positive number does not change the inequality. Now suppose if you have an equation like 5x greater than 5. If it is an equation, we will write it in the form of x is equal to 5 by 5. But here we'll not do like that because there is no process of shifting. So what we are supposed to do is we have to divide or we have to multiply the positive number each side by the same number. So what I'll do here, I'll divide by 5 on both sides. Then I'll get the equation x greater than 1. So that will be the solution. So this is applicable only for the positive numbers. Now in case if it is negative, let us see rule number 4. Multiplying or dividing each side of an inequation by the same negative number reverses the inequality. While adding, while subtracting, or while multiplying the positive number, the sign of the inequality doesn't change. But if it in case you are multiplying or dividing by the negative number, it is only applicable for multiplying or dividing by negative number, then you should change the sign of an inequality. For instance, you have here minus 5x less than 5. Now here I need the value of x, which means I don't want minus 5 in the left hand side. So I'll divide by minus 5 on both sides. Then what happens here? X, and here it becomes minus 1. But when you're dividing or multiplying by the negative number, you should change the sign of inequality. That means lesser than becomes greater than. So this forms a solution. Or if you have a greater than, then you should convert it into less than. Same in case of slack inequalities. Now let us find the solution of an inequation under the given conditions. The very first question we have, solve 30x less than 200 when x is a natural number and when x is an integer. So the very first question is, the condition is x is a natural number. So which means we need to take the solution only under natural number. The next thing is we have x is an integer. So what happens here? So 30x less than 200, we'll divide by 30 on both sides. Then we will get x less than 200 by 30. So 0, 0 cancels. So x less than 20 by 3. So when I say 20 by 3, so we have here 3 ones are 3 6 are 18. So we have 2 remainder. So which carries as 20 again. It is 6.666, which is in a decimal form. So this is almost approximately equal to 6.66. When I say x is a natural number, we know the set natural number always starts from 1. So the number which is less than 6.6 is 1, 2, 3, 4, 5, 6. So all the numbers which is less than 6.66 will form a solution for this inequation. So if you substitution 1 here, if you put x as 1 here, 30 less than 200, true. If you put x is equal to 2, 32s are 60, 60 less than 200, true. Next, similarly, if you take 6, so 3 6 are 18, 180. 180 less than 200, it's a true statement. So that means the solution set should make the given inequation as a true statement. So therefore, this is the set of natural number which forms the solution for the given inequation. Now, what happens when x is an integer? So we know that the maximum integer it can reach is 6, then 5, then 4, 3, 2, 1, 0, minus 1 until the minus infinity. So therefore, the integers which contains from minus infinity to 6, only the integers forms the solution for this inequation. Next, solve 5x minus 3 less than 7 when x is an integer and x is a real number. So let us find the solution. We have 5x minus 3 less than 7. I don't need minus 3 here. So I'll add plus 3 on both sides. Then I'll get 5x. Minus 3 plus 3 get cancels. Less than 7 plus 3 becomes 10. Then I'll divide by 5 on both sides. So 5 by 5 is x and 10 by 5 is 2. So x less than 2 forms the solution here. Now under integer, since it is strictly less than 2. So strictly less than means before 2. The integer is 1. Then before that 0, minus 1, minus 2. So this is the maximum integer which acts as a solution for this set. So therefore, under integer as a solution set, this is the solution. Now when we come across x belongs to real number, when x belongs to real number here, x belongs to the solution, less than 2 means we always write in an interval form. We have learnt in chapter 1 how to write the real number in the interval form. So when I say less than 2, it is an open interval with respect to 2, and here the last number is minus infinity. So therefore the solution set for the given inequation under real number is minus infinity to comma 2 and a open interval. Next, solve 5x minus 3 less than 3x plus 1 when x is an integer and when x is a real number. Now let's take here, we have 5x minus 3 less than 3x plus 1. I don't need minus 3 here, so I'll add plus 3 on both sides. So 5x minus 3 plus 3 cancels, 3x. When you add plus 3 here, it becomes 4. Now here I don't need 3x, so I'll subtract 3x on both sides. 5x minus 3x is 2x. 3x minus 3x is 0, 4. Now I need only x. I'll divide by 2 on both sides. Again, I'll get x less than 2. So x less than 2 means as x is an integer, the solution is from minus infinity, minus 1, 0, 1. And here the same solution we have minus infinity, comma 2. So this is the solution. Next, solve 3x minus 7 greater than 5x minus 1. When no conditions are given, we have to find the solution set always in the form of a real number. So now we have 3x minus 7 greater than 5x minus 1. So I'll add 7 on both sides to remove 7 on the left hand side. Then I'll get 5x minus 6. Minus 1 plus 7 is plus 6. Next, here I have to subtract 5x on both sides. 3x minus 5x is minus 2x greater than 6. Now I have minus 2 on the left hand side. So I'll divide by minus 2 on both sides. Then I'll get x here and I'll get minus 3 here. But whenever you're dividing by a negative number, you need to change the inequality sign. So therefore greater than become less than. So therefore the solution is x less than minus 3. So therefore x belongs to minus infinity, comma minus 3. So this is the solution set. That means all the numbers less than minus 3 will satisfy the given inequation. Next question, solve x by 3 greater than x by 3 plus 1. Now here, let us simplify this. Here it is a fraction. So we have x plus 3 whole divided by 3. To remove 3 on both sides, I'll multiply by 3. Then I'll get x greater than x plus 3 here. So now I'll multiply by 3 on both sides. Then x greater than 3x plus 6. So then I don't need x or 6 here. So then if I subtract it, then I'll get minus 2x greater than 6. Again, I have to divide by minus 2. So we get x less than minus 3, which forms the solution here. Next, 5 minus 2x divided by 3 less than or equal to x divided by 6 minus 5. So let us keep the left hand side as it is. We'll simplify the right hand side. This is x minus 5 6 are 30 divided by 6. Now let's take the LCM of 3 and 6 and we'll multiply on both sides. So which is 6. So when you multiply 6 here, 5 minus 2x divided by 3 less than or equal to x minus 30 by 6 multiply by 6. So 6 cancels here, then multiply 2 5s are 10 minus 2 2s are 4x less than or equal to x minus 30. I'll get 10 minus 5x less than or equal to minus 30. I'll add 10 on both sides, or I'll subtract 10 on both sides here. Then I'll get minus 5x less than or equal to minus 40. I'll divide by minus 5 on both sides. Then I'll get x greater than or equal to. So since we are dividing by minus 5, it is 8. The solution is x greater than or equal to 8. So when I say greater than or equal to, that means it's a slack inequality. It also includes 8. So greater than or equal to 8 means 8 until plus infinity. So therefore this is the solution. Next question, x divided by 4 less than 5x minus 2 by 3 minus 7x minus 3 by 5. So let us keep this as it is and we'll simplify the right hand side. So by taking the LCM here and cancelling this, we'll get here 25x minus 10 minus 21x plus 9 whole divided by 15. So now x divided by 4 less than 25x minus 21x is 4x. Minus 10 plus 9 is minus 1 divided by 15. So again, we'll take the LCM of 15 and 4, so which is 60. So if we multiply 60, then this is 15x less than or equal to, and here it gets cancelled 4s are, so 8x minus 4. Now we'll subtract 8x on both sides, so we will get 7x less than minus 4. So x less than minus 4 by 7. We have only the positive values of x. So even though the answer is negative, you can't change. Only when you're dividing by negative number, you can change the inequality. Now the solution set is, so minus 4 by 7, comma, minus infinity here. So therefore the solution set lies from minus infinity, comma, minus 4 by 7. So in this session, we have learned how to solve the linear inequalities. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.